Hey everyone, welcome back. Excited to be here today. My name is Joe, and I'm an engineering manager at Meta on the PyTorch team. And I'm joined virtually by Geeta Chauhan, who will be joining us for the second half of the talk. So excited to co-present the state of PyTorch, which has become a little bit of an annual tradition to give a lightning overview of some of our major feature launches, talk a little bit about some metrics and growth, and help celebrate all of you who have helped to make PyTorch the success that it is today. So kind of in that order, talk about some feature launches, do a little deep dive into research community using PyTorch, back out to the community at large, and then finally hand it over to Geeta for industry. So first up, we're excited to have had 3 major releases this year, 1.11, 12, and 13, constituting somewhere around 10,000 commits from hundreds of developers. So thank you all for that. You've heard about many of these major feature releases throughout the day today in talks and in the poster sessions, but just to re-highlight, we have Torch Data, Torch Arrow, new libraries for common modular data loading primitives, for constructing flexible and performant data pipelines, and for pre-processing of our batch data. We've upstreamed FuncTorch, a library that adds composable function transforms into PyTorch for familiar APIs like VMAP and GRAD, JVP and VJP, enabling things like per-sample gradients. We're excited of our launch of FSDP, fully sharded data parallel, enable training of large AI models by sharding model parameters, gradients, and optimizer states across multiple machines. One of our most highly requested and commented on issues on all of GitHub, Apple M1 support. So we're excited to launch acceleration on Mac to now take advantage of Apple native Silicon GPUs for significantly faster model training. We had a poster session on Better Transformer. So this is kind of out-of-the-box performance wins on CPU and GPU for fast-path implementations of transformer encoder layer and for multi-head attention. NVFuser is our new deep learning compiler for PyTorch, supporting a wider range of operations, faster speeds, and TorchScript has been updated to use it by default. And finally, we're incredibly excited about our new domain library launches for TorchRec and Torch Multimodal. On the rec side, having a common sparsity and parallelism primitives for high-speed recommendation systems, and on the multimodal side, having this composable building blocks for training state-of-the-art MTML models. So backing up a little bit, we're excited that we can now observe over 350,000 GitHub repos that use PyTorch available. And that's about a 45% growth year over year. I don't think it would be fair to be adjacent to the NeurIPS conference without taking a little time to dive into researcher usage. So we see over 9,000 GitHub repos that can be associated with AI research papers from this year via Papers with Code. And that constitutes somewhere around 63% of all AI research implementations choosing PyTorch, and a 4% growth. With the Cambrian explosion of AI, it would be impossible to get into every single domain that is currently using PyTorch, but just to highlight a few we're excited about. On the generative modeling side, we have researchers at FAIR who have built Make-A-Video to be able to take as input a text prompt and generate these kind of whimsical, one-of-a-kind videos. PyTorch is being used in next-generation therapeutics with researchers at Asimov using PyTorch to generate optimal programs for living cells to produce next-generation therapeutics. And on the graph neural network side, Kumo AI is using PyTorch alongside the popular PyTorch Geometric to build, train, and scale large-scale graph neural networks. So talking a bit about the community, as I mentioned earlier, we have over 11,000 commits over the past 12-month period, with more than 3,000 unique contributors, which is crazy, and a 20% increase year over year. So I just want to thank all of you for kind of coming here and contributing to PyTorch. There's a little bit of a technical issue, so we aren't able to have a scroll with everyone's username who's contributed over the last year. So this is a random sample size of individuals, but whether you've contributed documentation or bug fixes, low-level performance optimizations, high-level API design, we appreciate all of your contributions. And finally, there's contributors from major organizations as well who have helped with everything from fast kernel development to supporting different devices, integrations into cloud providers to make it easier for AI researchers and developers around the world to be able to use PyTorch. So thank you all for coming in. And lastly, I just want to highlight one of my favorite aspects of all of PyTorch, which is community engagement. It's incredible to me that we have over 2 million views of our PyTorch discussion forum. There's been over 20,000 replies to community questions and concerns and bugs. So thank you for being active on there and getting out there and helping the community. And over 3,000 contributors to that. So with that, let me hand it over to Geeta to talk about industry usage.
Thanks, Joe. I lead the Applied AI group at Meta. We collaborate with leading companies across the industry for PyTorch adoption and integrations. I will share some of the key highlights from our work in 2022. From the latest LinkedIn talent report, we are seeing more than 44,000 professionals have tagged PyTorch as a skill set on their LinkedIn profile. And there are 2,500 plus related jobs for PyTorch on LinkedIn now. Overall, this is a 50% year-over-year increase in PyTorch professionals just this year. With the cloud providers, our focus this year has been on large foundation models. With AWS, we enabled the launch of the Trainium ML chips for training large language models and seeing near linear scaling across the Trainium clusters. Further, in a three-way partnership with Google, AWS contributed the XLA backend to the PyTorch distributed to ease migration of training workloads onto the Trainium chips. With Microsoft Azure, we launched the PyTorch Azure Containers and the DeepSpeed MII library, a new open source library that speeds up model inference and at a lower cost point with built-in support for more than 24,000 models. With Google Cloud, we launched the PyTorch XLA profiler for the cloud TPUs to help with troubleshooting and profiling large training runs. We also added support for the fully sharded data parallel to PyTorch XLA and launched the OpenXLA project for community-based ML compiler and infrastructure projects, which includes the XLA compiler and the stable HLR. We saw many exciting startups emerge in the AI space. I would like to highlight a few. Stability.ai, best known for the open sourcing of stable diffusion models, is building open AI tools for developing cutting-edge AI models for generative art, music, language, videos, 3D, and biology. Predibase offers an alternative to AutoML and uses a declarative approach to building AI models. Their Ludwig library, a Linux Foundation project, has migrated to PyTorch from TensorFlow, and we collaborated with them to add support for scriptable tokenizers to Torch text. Fashable is a startup focusing on AI-generated fashion for clothing design for the fashion industry, for faster time to market and reducing waste. We helped their team to speed up their GAN-based model training in collaboration with Microsoft Azure. We are seeing a rise in the software vendors building libraries and solutions on top of PyTorch. Hugging Face, a standing partner known for the Transformer libraries. This year, they added support for Accelerate to speed up distributed training and inference, and diffusers for the diffusion models. We have collaborated with them to integrate better transformers and fully sharded data parallel. Elasticsearch, the search engine platform, has added embedded PyTorch support for NLP models by integrating libtorch into the Elasticsearch stack, making it easy for developers to perform tasks like named entity recognition, sentiment analysis, and more from right inside the Elasticsearch itself without having to make an external call. MosaicML is another emerging startup with focus on efficient model training. Their PyTorch-based library Composer enables training neural networks faster and at a lower cost point. They recently launched their own cloud offering, and we are collaborating with them on integrations for FSTP and Torch data. We are seeing a rise in the production use cases of PyTorch across the industry. I would like to highlight a few. On the Tesla AI Day, Tesla shared details of how they're using PyTorch, not just in the self-driving car, but also as part of their Dojo superclusters and their new AI accelerator, with Dojo extensions for PyTorch and their new compiler engine. With Disney, we collaborated on their new multimodal-based activity recognition solution for the media production field, where they combined insights from audio, video, and subtitles to get better results. Amazon Search is using large-scale models across multiple modalities to power their discovery engine for Amazon. Their M5 team runs thousands of experiments and training jobs each month and is quickly able to roll them into production. They make use of PyTorch Distributed, ES3 plugin, PyTorch Profiler, and are migrating to FSTP. We are excited to see these great uptakes of PyTorch across the industry. You will hear from many of our partners on the talks today, along with the poster sessions. For more case studies, please check out the PyTorch community stories and Medium channel. I will now hand it back to Joe. Thanks.
All right, thanks, Geeta. And thank you all for coming out today and for being part of the PyTorch community. Hope to see you all on GitHub.